All right, in this example, we're asked to find the indefinite integrals below. All right, so remember the indefinite integral just asks us to find the antiderivative of this function, right? So we're trying to find a function that has this derivative. So let's think about this one, the integral of x cubed. Well, I haven't given you the rules yet, so let's think about what function might have a derivative of x cubed. Well, I know that if I find the derivative, I'll write this down here, um, derivative of x to the fourth, right? I know that derivative is equal to 4x cubed. Okay, we're close, right? We're kind of just off by a constant. Okay, so what would happen if I just multiply both sides by 1/4? Right? I'm just going to multiply both sides by 1/4. And then you can see the 1/4 times 4 just becomes 1. Okay? So, so that's telling me that again, I can, I have a constant multiple of a derivative, so I can just write that as 1/4 x to the fourth. All right? Now, I want to find all of the antiderivatives, so I'm going to add a plus c to it. Okay, so make sure you add the plus c. All right, so there's the indefinite integral of x cubed. All right, and you can always check. You can take the derivative of our antiderivative, and you should get x cubed. All right, because that's what it means to be an antiderivative. All right, let's look at the next one. We have e to the 2x. We're trying to find the antiderivative of e to the 2x. So let's think about this again. I know that the derivative of e to the 2x is equal to, I have to use the chain rule, so I get e to the 2x, and then I use the chain rule on it, and I get, come on, and I get 2e to the 2x, right? 2e to the 2x. Come on. All right, 2e to the 2x. Again, it's close, right? It's close to what I want. So if I just multiply both sides by 1/2, right, I'm going to multiply this by 1/2, and then the 1/2, come on, 1/2, goodness. Okay, the 1/2 will cancel with the 2. And then I have, so then I have 1/2 e to the 2x. That will have a derivative of e to the 2x. So my antiderivative is 1/2 e to the 2x. All right, let's take a look at the cosine function. All right, so now I know that the derivative of sine is cosine, right? So I'm guessing it's got to be sine. And let's try pi x. All right, so let's take the derivative of that. I take the derivative of the sine of pi x. What do I get? I get cosine of pi x, right? And then I have to use the chain rule, so I multiply that by pi. Okay? So again, I'm close. I just have this extra constant in here of pi, so if I just multiply both sides by 1/pi, right, then I should have it. So this will be 1/pi, 1/pi sine of pi x, okay? And then plus a c. Whoops, come on. Plus c. All right, so again, you can always check this by taking the derivative of the antiderivative, and it should give you the original function back, right? Whatever the integrand is here. So, all right, got one more. Secant squared. All right. Well, if you recall, the derivative of tangent of x, come on, tangent of x is equal to secant squared of x. Oh, come on. All right. Right. So there we go. That's it. The derivative, the antiderivative is tangent of x. And then, of course, we're going to add a constant to it. Let's see. Did I lose my constant up here? Or did I forget to do it? All right. I'm going to add a constant to it. And, to get the general solution of get all of the antiderivatives, right? Get the whole family of antiderivatives. Alrighty. So I'll see you in the next video for the next example.